Before we start, let's recall a choral of our great visionary and philosopher Sri Tiruvalluvarji. Choral number 32 from Thirukural, where he wrote,
அறத்தினொங்கு ஆக்கமும் இல்லை அதனை மறத்தலின் ஊங்கில்லை கேடு.
whenever we talk about the idea of reinforcement learning in the context of machine learning, we tend to put too much focus on the optimal control part, where we talk about designing optimal solutions using value functions and dynamic programming. Then we explore the Markov decision processes, and from there we generally directly move towards the Monte Carlo methods, the temporal reference learning algorithms, and so on and so forth. And this is how some of the most popular and widely used books on reinforcement learning are framed too. And almost all popular definitions of reinforcement learning that are available, from Wikipedia to popular tech journals, are designed like this. So, one thing is common in all these definitions is that they all talk about the optimal control part and the trial and error approach. But this is where the problem starts. Without exploring the foundational ideas, the core ideas behind reinforcement learning, our understanding of the mathematical models and computational algorithms remain incomplete. While these concepts are important too in the design and development of RL based systems, but we cannot ignore the fact that the very foundational idea behind reinforcement learning has its roots in the behavior, psychology, and its experiments. So let's take a quick overview of the real and the least talked about background of reinforcement learning, which plays a crucial role in the machine learning developments. We know that in RL, reinforcement learning, which is a reward based model, the core components are an agent and the environment. The agent observes the state of the environment and applies an action to the environment to receive a reward. But how those rewards and the schedule of those rewards and reinforcements is designed is not a mathematical model. It's a psychological concept, which is largely influenced by one of the most radical behaviorists of 20th century, B.F. Skinner, Borges Frederick Skinner. After receiving a good amount of funding from the US military to set up the Project Pigeon, a proposal to use living organisms to guide missiles during the course of his experiments, B.F. Skinner realized the power of behavior shaping methods, which in simple words means rewarding an animal for a desired behavior or response and punishing him for doing the opposite. Encouraged by the response to his ideas, Skinner continued his experiments to test his ideas of behavior shaping on rats, pigeons, and other testable animals, and developed a doctrine called technology of behavior, which is also known as a technology of behavior modification. So, this is a copy of the paper which he published, and those who want to explore more on this can access it from the bfskinner.org website. Later, he designed an operant conditioning chamber called the Skinner box, a soundproof enclosure with a food dispenser that a rat can operate by pressing a lever or a pigeon by picking a key. One of the key discoveries from those experiments with the Skinner box was the schedule of reinforcements or rewards. And based on that, he devised different ways of delivering rewards as per the response rate of animals. And he insisted that a procedure in which behavior is reinforced or rewarded after scheduled but unpredictable time durations yield the most stable rate of response. It means that if an animal knows he will get some rewards for his particular behavior, but the timing for that is not fixed, it is unpredictable, then he can be tempted to do more, as long as the person who controls the box and the lever of rewards wants. This is how all gambling, casino systems, and now the social media platforms work. And that's why they're highly addictive too. So, these operant conditioning chambers, as we know, have become common in a variety of research disciplines, especially in animal learning and psychology. So, in a nutshell, Skinner found that the environment influences behavior, and when that environment is manipulated, behavior will change. Skinner's theory of operant conditioning played a key role in helping psychologists understand how behavior is learned, which later contributed in the design of reinforcement learning and machine learning algorithms too. So, before starting straight with the development of mathematical models, one must have some understanding about its background, which is not merely based on making an agent to learn through trial and error approach, but also involves performing some conditioning of his behavior through schedule of reinforcements and rewards. Well, a very few people know that later Skinner wrote a sci-fi novel called Walden 2, somewhere in 1948, where he visualized a perfectly socially engineered society working as per his principles of operant conditioning. And he is also the man behind the user experience of the world's first computer network and the first social media platform, too. So, this is all about a quick overview of the background of reinforcement learning. Now, the question is where the current trajectory of reinforcement learning and the RL driven machine learning systems is going. And those who are driving this change, what are their views for the future? We'll explore that in the next part.